So the second part of our class, in our previous class, we determined the angle. Yeah, we did determine the angle. And then from there, now to find the outer rail, remember we said that we have these rails that are coming in like that. And then we have calculated this angle. So we know that the distance between one rail and the other rail is 1.5. What about, so the question was to calculate how the outer rail is raised, how much the outer rail is raised. So we want to find this h. Given this hypotenuse, we have our hypotenuse, we have our angle. We can use that to find our height, and which is 0.059 meters, or we can even put it as 6 centimeters. Whichever way, we can even leave our answer like this, will be correct, and we can even break it down to centimeters, will still be correct, as long as we have found what they were asking for. Is that okay?
Yes.
Okay. So we are going to the next question, and the next question, can we have Mr. Gilbert read for us this question? The next question, I think that will be our last question. Let's also look at this question.
As shown in the figure below, calculate the force necessary to keep a mass of 0.8 kilogram revolving in a horizontal circle of radius 0.7 meters.
Sorry, okay, you have read it, right? But then the question continues.
Okay, 1, 2, calculate the direction of this force. Then 3, calculate also the tension in the string.
Awesome, awesome. So here, obviously, we're even supposed to have some angle, like, yeah, some theta. So, as shown below, part A is talking about calculating a force. Obviously, it's going to be centripetal force, and this force will keep the calculated force necessary to keep a mass of 8 kg revolving in a horizontal circle of radius 0.7 meters with a period of 0.5 seconds. All right, period of 25.5, meaning 0.5 seconds. Do we all know what period is? Do we know what period is? Sometimes they give it the symbol T. Anyone who can give us a definition for period?
The time.
Yeah. You can go on.
I guess the time taken for one complete revolution.
Yes, yes. It is a time taken to complete one revolution. So if one revolution is like this, and then it takes 0.5 seconds, then the period is indeed 0.5 seconds. So it's the time taken to complete one revolution. And that's our period. Our frequency is, of course, 1/period. Now, from this information, knowing that we have 1/5 as our period, or I mean 0.5 as our period, what can we do? All right. So we have our mass in our data, 0.8. We have the radius of this circular path, 0.7. And then we have, of course, we know that our period, as this, what's this? As this ball will be revolving in this circular path the period will be the time, if it starts from here at 0 and then comes back here, and comes back at this point in a time of 0.5 seconds, meaning to calculate the angular velocity of this particular ball, angular velocity will be 1 revolution over the time taken. The time taken was 0.5 seconds. So 1 revolution over 0.5 seconds, we have our angular velocity as 2 revolutions per second. So meaning it can take, it can do 2 revolutions in 1 second. Are we okay on how we have found the angular velocity?
Yes.
Yes.
All right, Tekla, are you with us?
Yes.
Awesome. So, yeah, we have found our force, our angular velocity, we have determined it. Now, remember the question is saying, calculate the force necessary to keep the mass of this much in revolving in this radius at this period. So it means that for us to find that force, I already mentioned that that force will definitely be centripetal force. With the data that we have, they are saying for us to find this force, with the data that we have, we know that this force, we can calculate it by mass times centripetal acceleration. We have our mass times our velocity squared over r. And we know that this expression, v squared over r, we can also express it as r times c omega squared. Do we know how we come up with this expression of r omega squared from this expression? Do we know how we come up with it? Anyone who doesn't know, maybe let me ask. Anyone who doesn't know how we come up with it? Don't be afraid to ask. You just ask so we can tell you how we come up from v squared over r to r omega squared. Is there anyone who doesn't know how this comes up? Okay, seems we all know. So then we continue. But we know that this omega, we need to have it in terms of radians. We need to have it in terms of rads per second. Now, we have it in, here we have it in revolutions per second. Changing to rads per second, we just, we know that we have here 2 revolutions over 1 second. Now, the revolution, we can also express it as 2 pi r. So revolution is the same as 2 pi r. So this revolution and that revolution will cancel out. And then here we'll have 2 times that 2 pi rad over this second. Of course, I was even supposed to indicate second there. Gives us 4 pi radians over per second. Yeah. So from there, we can now express this, having known now our angular velocity, we can just plug it in our equation and solve for the centripetal force. We have our mass times our radius times our angular velocity squared. And therefore, we have our force required to keep the ball revolving. Are we okay on how on what to found?
Sir.
Yes.
For that W, are we not supposed to not W, I mean. The angular velocity, are we not supposed to like divide it by, like divide the two revolution divide by the time it took for one complete revolution? Since they're saying it took one complete revolution, and then we divide it by the time, which is 0.5, where it gives us instead of 4 rad, it would give us 2 pi rad as our angular velocity. All right.
So you are saying here we calculated that our angular velocity will be 2 revolutions per second. Now, what's your question?
I get it. I forgot you already did it.
Okay. Okay. So are we all okay on how I found our centripetal force? Or in fact, here they didn't even say find the centripetal force. They just said calculate the force necessary to keep the mass revolving. So the keyword is revolving. So when something is revolving, we know that obviously there will be a force called the centripetal force. All right. So they will not always say calculate centripetal force. In fact, obviously they will never even say calculate centripetal force. They'll always put in a twisting language, but you always have to know what they are asking for. Of course, this was an examination question, as you can see. And so this is how simple it was to calculate that force. All right. And this is how I've calculated it. So we got the second part. The second part is saying calculate the direction of the force. So that force we have found, can we calculate its direction? So we know that this force which we have found is in the x-axis. If I'm to draw my Cartesian plane like that, I know that this is x and that is y. So how can I determine the direction of this force? So I need to do summation of forces. I need to do summation of forces in the x-axis. Now here, summation of forces in the x-axis will be equal to 0 because we don't see the ball spiraling or going away. It hasn't gone away from this circular path. It's still in this circular path. So since the ball is still in the circular path, meaning all summation of 4 forces is equal to 0. Now, what forces do we have in the x-axis? We have this force that we have found, centripetal force. It is not at an angle, so we don't have an angle attached to it. We have centripetal force. Then we also have T sine theta. Where is the T sine theta coming from? Is because this tension, whenever something has an angle attached to it, we know that it has also a component of it in the x-axis. So since tension has an angle attached to it, we know that tension also has some component in the x-axis. All right. So that's how come we have said T sine theta. Why are we putting a negative to the theta? In fact, if you heard me clearly when we started our meeting, I said that I will even tell you some of the concepts behind negative angles and positive angles. So if we have our Cartesian plane like this, and we have, say, an angle given below the positive x-axis, this angle is a negative angle. Are you getting me?
Yes, sir.
If we have an angle below the x-axis taken like this angle is a what? A negative angle. All right. And this angle is not the only angle which is negative. Actually, if you extend this force in that direction, it also shows us that even this angle is a negative angle. So this angle and this angle will be negative angles because, of course, because opposite angles are always equal. So if this one is negative theta, Even this one will be negative theta. So in your calculations, if you find that maybe your angle is negative 29, what should come to your mind is that it is either taken from below the positive x-axis or above the negative x-axis. Are we together?
Yes, sir.
So far?
Yes.
We are following so
Yes,
far?
I did.
Okay.
Yes, we are.
Okay. Thank you. So now, that is how come. Have you seen where this angle is taken? Say if, for example, if this was our Cartesian plane and that was our x-axis and this was our y-axis. All right. So now we also have a situation whereby this angle is also taken. Now in this case, this angle is not taken here, it is taken down there. Now, what does it mean? In fact, one thing that I should have explained is that, remember, sometimes if we want, we can take our angles with respect to the y-axis, or we can take our angles with respect to the what? To the x-axis. So if we have taken our angles with respect to the x-axis, where this will be a negative angle, and that will be our negative angle. If the angle is taken with respect to the x-axis, if the angle is taken with respect to the what? To the y-axis. If the angle is taken with respect to the y-axis, this is a negative angle. Even there, it will be a negative angle. Here it is negative because it is taken with respect to the negative y-axis. All right. And there it is negative because of opposite angles. Opposite angles are always the same. So here again, this will be a negative angle. So only in this quadrant and in that quadrant do we have positive angles. Theta is positive only in this quadrant and in that quadrant. Are we together?
Yes, sir.
Are we together?
Yes.
Yes.
So if we find a positive angle, if we find an angle of 29 degrees, where do we know? We know that it is either in the first quadrant or in the what? In the third quadrant. Is that okay?
Yeah.
Yes.
Awesome. So since this angle, so here it's angles. Do you know that angles help us to know the direction? So in here, for us to know the direction of the force, no wonder we are bothering ourselves with the angles. So we know that this centripetal force, it has no angle attached to it because it's flat. It's flat out. But we can relate it to this other, to tension, which has an angle attached to it. If we can know the angle of this tension, it will be easier for us to know something about the direction also of this force, centripetal force. So for us to know the direction, we must look at the angles that are at play. So no wonder, looking at the tension because tension has been taken, remember tension is here. So tension, like that. Tension has been taken with an angle which is negative with respect to the y-axis. No wonder, since it is respect to the y-axis, in the x-axis, we are even using the sine function because the angle has been taken with respect to the y-axis. And this angle is a negative angle, all right? It's a negative angle. So have you already done trigonometry, or have you done trigonometry in maths? Have you done trigonometry in maths in NS?
No,
No.
not yet.
Okay. Or have you done, in fact, even and odd functions are also one of the, or the first topics that you do in NS. Have you done even and the odd functions?
Yes, yes, sir.
Yes.
You have done them, huh? Sine function is called a what? Sine function. For example, sine x. Is it even or it's odd? Hello? Kalma. Is sine function even or odd?
It's even.
Okay, that's Kalma. Tekla, is sine function even or odd?
I'm not sure, but I think it might be odd. I'm not sure.
So it's a case of when you have two options, it's either even or it's odd. So sine function is odd. Sine function is an odd function. And an odd function, it means that if we have sine of a negative angle, say for example, sine of negative x is equals to what? Is equals to negative sine x. That is what an odd function is. So here, t sine negative theta is the same as negative sine theta. So we can remove this negative in these brackets and take it outside, and the negative will come here. So, but if we had cos theta, or should I say cos x, cos minus x, since cos is a positive, or should I say it's an even function, then you would find that this expression is equal to cos x. So the negative disappears, just like that. So with cos, since it is an even function, we find that cos negative angle is equals to just cos that angle, cos x. So if we had cos here, the sign would have maintained. But since here we have a negative angle, the sign has been taken to the other, to outside here, and that's how come we have a negative angle here. I mean the negative sign. So with this equation, what if we have a certain parameter or a certain number minus a negative? We have a negative. So a certain angle, a certain number minus a certain number, what does it tell you? Does it tell you that this one can be, so what do you think can be the sign to this one? If we have x minus y, we have already been told that y is negative, and then they tell you this expression should be equal to 0. What do you think should be the value of this x? Should it be a negative? Should it have a negative number or a positive number?
Positive number.
It should have a positive what? Number. So earlier on, we just calculated the number without the sign. All right. So now here, when we have seen this expression that this t sine theta expression is a negative expression, meaning our centripetal force has to be a what? A positive number. It has to have a positive sign. So since the sine function is odd, we have come up with this expression. Now this can only be true, this expression can only be true if the centripetal force is positive. So therefore, we can determine that the direction of centripetal force, since we are dealing with the positive, since we are in the x-axis, direction of the centripetal force will be towards where? Someone to help us. Where would it be? What will be the direction of the centripetal force?
Positive direction, the x-axis.
It will be in the positive x-axis, right? The direction will be positive, right?
Yes.
So have we seen that all in all, even if no one taught you these things in high school or in school, you can use mathematics, any knowledge that you have to be able to come up with the answer. And you can get this question correct by just showing this expression. You show summation of forces in the x-axis, you show this expression, and then you even tell them to say, this expression that we have is only true if force X is positive. And therefore, the direction of this force is what? Towards the positive x-axis. So it's a positive force towards the positive x-axis. So that is how come we get the answer there. All right, are we okay with this solution?
But sir.
Yes.
Yes. Since the mass it's rotating, will the direction of the force not keep on changing? It goes to the positive, to the north, to the south, such kind of a thing.
Okay. Will the direction of the force be changing since the mass is so in this case, the direction of the force in this case, since we have a circle like this, like I said, if you don't want to say direction towards the positive x-axis, you can also say direction outward, away from the center. So you say that it is away from the center. You can even say away. Once you write towards the positive x-axis, you can even put in the brackets and say away from the center of rotation, the center of rotation. It will be away from the center of rotation. Good question, actually. Good question in saying, since it is always rotating, this is the positive x-axis, and when it is here, it will be towards the negative x-axis. But I guess also the other accurate way of the time of stating it is that it is away from the center. All right. So if it was negative, then it would have been towards the center of the axis, towards the center of the curve or the rotation, the circular path. So can we move on, or anyone also has a question? We are moving on to the last part, which is saying also calculate the tension in the string. Okay, so since we don't want also to keep you guys waiting, let me quickly go through the last part. Tension in the string. So we know that we have a situation where we have something like this, right? We have rotating in that circular path, like that. So we know that tension is always pointing in this direction, but we also have the weight of this ball. So since we have the weight of this ball, this weight of this ball will be also adding in some forces. So such that when we sum forces in the y-axis, this now, since we have been given this angle here, our tension, its component in the y-axis will be T cos the angle that we have been given. All right, because since the angle is taken with respect to the y-axis, so the y component of the tension will be like that. So now, When we sum forces in the y-axis, tension is pointing upward, and we see the weight, which is mg, pointing downward. We see that we can take mg to the other side and have mg like that. And substituting, we know the mass, we're given the mass, we know also acceleration. Then we can also find our component of tension in the y-axis. Now, we know that in the x-axis, we had made an equation, equation 1, where we said Fc minus T sine theta is equals to 0. So in this equation, we don't know our theta. We also don't know our T. So we need another equation that we can use, we can solve simultaneously so that we can either find our T or our sine theta, and from there we can continue. So in this expression where we have just expressed the forces in the y-axis, we see that we have come up with this expression for T cos theta is equals to this expression here. Now, in equation 1, we have that Fc minus T sine theta is equals to that. We can take T sine theta on the other side, which can give us an expression of saying T sine theta is equals to, remember our centripetal force, we calculated it as this value. So then we can divide this equation by that equation. All right, so we have this equation coming over here and saying T sine theta is equals to 88.43 over T cos theta is equals to 7.48. What then can we do from here? What we can do from here is divide. So T will cancel with that T. Sine theta divided by cos theta, we have tan theta, 88.0, that divided by that. Okay, so here, I think I calculated the angle in advance. I should have shown the process. All right, because actually the angle now is equal to this one. So we have found the angle. I should have shown the process of saying T sine theta, tan theta is equals to this divided by that, and then we do tan inverse. I'm sure you know how to go about solving an angle once you have this expression. But when I'll be sending the notes to you, I'll make sure I correct it and put the stages. But otherwise, from there, we can find the angle as this value. And then after finding the angle, then what can we do? We can go back to this expression and say that my T will now be equal to 88.4 over what? Over sine theta, you know? And that is what we have here, 88.43 over sine theta, and we get our tension like that. So, yeah, that is how we solve examination questions, and that is how you get an A+ in physics. So, anyone who is behind who needs a bit of some clarification? Kawama, you are okay with the explanation?
Yes, I'm fine, but I'll go through again, and if I find anything, I'll ask.
Okay. Simbarashe?
I'm okay, sir.
Gilbert?
Yeah, it's good.
Okay, so I guess our friends today, most of them, maybe they were busy doing other things. But anyway, have a good day, and I'll send the homework. You must do the homework, and awesome. See you on if God wills, on Wednesday. In fact, I had sent in the anyway. See you. Have a good day.
Thank you, sir.
Awesome.